Class, let's solve some simple equation with indices and logarithm. So we can say logarithmic and or indica equation is what we are looking at here. Then let's look at the first question here. We have 9 raised to power 2x plus 1, 9 raised to power 2x plus 1 excuse me, equals to 81 raised to power x minus 2, then divided by 3 raised to power x. Now, to solve this particular equation with indices, we can change everything to have the same base. That is, the least base here will be base 3. So we can change 9 to 3 square. Then, which is raised to power also 2x plus 1, yeah, and equals to 81 here, we can write that as 3 raised to power 4, then into bracket x minus 2 there, then over 3 raised to power x. And here, this bracket, we can expand it. That is 2 multiply here. And this becomes 3 raised to power 4x plus 2 here. Then equals to, here we have 3 raised to power 4x minus 2 here. Then over 3 raised to power x. That is, from here, when we have same base and we have a raised to power m over a raised to power n, this same thing as a raised to power m minus n. So we can subtract this x from this power, and this becomes 3 raised to power 4x plus 2 now equals to 3 raised to power 4x minus 2 minus x. And here we have 4x minus x, that's 3x. That is, here we have 3 raised to power 4x plus 2 now equals to 3 raised to power 3x minus 2. Then we have same base. It implies we can equate the power here. From when we have a raised to power m equals to a raised to power n, here we can say that m is equal to n. That is, here we equate this and we have 4x plus 2 equals to 3x minus 2. Now, by the time we collect the like terms, bring x to one side, take 3x to this side, so we have 4x minus 3x, then equals to, we already have minus 2 here, then take plus 2 here, also become minus 2. And here we have 4x minus 3x, that's same thing as x, now equals to minus 2 minus 2, that's minus 4. So from here now, we have x equals to minus 4. So that is what we have. And thank you for joining us here at Master T Math Class. Then, let's solve another one on this particular topic. That is equation, simple equation with indices. Okay. Oh, sorry. I think there was a mistake somewhere here. Excuse me. There was a mistake. When we open this bracket, okay, we're supposed to be having 4 times minus 2 here. All right. That is 4 times minus 2 is supposed to be minus 8. So this power should be minus 8. And if we have minus 8 here, this is minus 8 and this is minus 8. Okay, sorry about that. And also here, this will be minus 8. So we have minus 8 minus 2, and this will be minus 10 now. All right. So when we are expanding bracket, we should be careful of what we are doing so as not to make that kind of mistake. Okay. So now let's look at the next one. Also involving logarithm. This one is involving logarithm. Now solve for x in this equation. So we have solve for x in log x to base 10 equals to 2. Now, this particular equation is involving logarithm. To solve for x here, we can use the relationship between indices and logarithm. From where we have log x base a equals to n. For us to transform this to index form, this is simply going to be a raised to power n equals to x. A raised to power n will now be equals to x. Now, the base of this logarithm is still serving as the base of the index, which is raised to power what is on the right hand side. So a raised to power n equals to x. When we relate that here, we can say this is 10 raised to power 2 equals to x. And 10 raised to power 2, that's 100. So 100 equals to x. So we can say that x equals to 100 from here. So that is that. X equals to 100. Then let's look at this as well. We are to evaluate okay. So sorry about the light breaking lighting system. So let's look at this. From what we have, the next question we have evaluates log 3 to base 9. So from here, we have log 3 to base 9. So we can say let this be equals to a letter x. And then from the relationship which we have, when we have log x to base a equals to n, which is same thing as a raised to power n equals to x. So this is the relationship between logarithm and indices. That is, from here now, we can say this is 9 raised to power x equals to 3 from here. Then changing this side as well to base 3. So we have 3 square. That's 9. Then raised to power x, then equals to 3, which is raised to power 1 here. Then, yeah, this power multiplies. So we can say this is 3 raised to power 2x equals to 3 raised to power 1. Then the base are equal here. So here we have 2x now equals to 1. Then to get x, it implies we divide both side by 2 here. Divide this side by 2, divide this side by 2. Here 2 cancel each other, and we have x equals to half from here. So that is that. And also, let's look at another question here. We have 6 log x plus 4 equals to log 64. Now, to solve this equation involving logarithm, we can apply the law of logarithm here. From the power law of logarithm, when we have p log m, we can write this as log m raised to power p. So we can reverse this also. That is, here 6 can go up here, and we write this as log x plus 4 all raised to power 6 now equals to log 64. Here we can express 64 as a number a power of 6. That will be 2 raised to power 6. That is 2 multiply itself 6 times. That will give us 64. Then next step here, the log here can cancel out. Then what we have left become x plus 4 raised to power 6 now equals to 2 raised to power 6. Normally, this is supposed to be having 6 solutions, okay? When we solve this properly here, it's going to give us 6 solutions, but sometimes you might just take the 6 truth on both sides, or you multiply both power by 1 over 6. So that here, this remains x plus 4, then equals to 2. Then by the time you take 4 to this side, it becomes minus. So we have x now equals to 2 minus 4. Then you have x equals to minus 2. Okay, which is one of the solutions there. Then, also let's look at this. Equation involving indices here. We have 4 raised to power x plus 1 equals to 8 raised to power x. That is, from here, we change both sides to have the same base. Here we can change it to base 2. That's 2 raised to power 2. Then raised to power x plus 1 here equals to 8. Also, that's 2 raised to power 3. Then raised to power x. Then here, 2 can multiply x and 1. So this becomes 2 raised to power 2x plus 2 here. That equals to also 3 multiply x. We have 2 raised to power 3x. Then we have same base now. We can equate the power, and we have 2x plus 2 equals to 3x. Now bring the like terms to one side. We can take 2x here, leave 2 here. So 2 now equals to 3x. 2x become minus 2x. And we have 2 now equals to 3x minus 2x, that's x, which is same thing as x equals to 2. So here we have the value of x in this problem as 2. Now, We continue from here in our next class. Subscribe in order not to miss out. And thank you for joining. See you in our next class, and bye for now.